analysis. Welcome to Chapter 3, Lesson 4 notes, and we're going to solve absolute value inequalities this time. So we did some absolute value equations. We reminded ourselves that absolute value, oh my God, this room is Antarctica. Oh. Anyway, we reminded ourselves that absolute value is just a distance away from zero, right? So we use this example, of course, the absolute value of 7 is 7. The absolute value of -7 is also 7 because we're talking about a distance away from zero. So how many places away from zero are we? Once we had kind of gotten into that mode, then what we did was we solved some equations, knowing that what's inside the absolute value bars could either be a positive 26 or a negative 26, which means this stuff that's got a variable in it could either be one of two things, a positive 26, or that stuff could be a negative 26. So really, in order to solve absolute value equations, you have two scenarios. Your first scenario is just drop the absolute value bars and bring down the number on the other side. So a quick walkthrough gives us, let's see, 8. And then what if that stuff that was inside the absolute value bars was actually a negative 26? A quick walkthrough over here gives us a fraction, which we could call negative 28 thirds, or up to you if you want to do this repeating decimal. Yeah, I know. Negative 9.3 repeating. So totally up to you which one you want to use, but either of those are the number that would go in there. And again, we're saying that either inside this stuff in here was either a 26 or a negative 26. And when you took the absolute value of it, you got this. That's why we're working it that direction. Okay, two scenarios. It was either one of those two that came out. Now, when you have stuff next to your absolute value bars, you have to move it away to the other side of the equal sign by opposite operations. Okay, so in this case, we're going to move this 15 by subtracting it so that we can get our absolute value bars alone. And 5 minus 15 is negative 10. Now, since absolute value bars cannot equal, when they are all alone, those absolute value bars all alone cannot equal a negative number, you have no solutions in this particular case because that is not a possibility, which means there's no real number that makes X true. And that's it. Raise your hand if you've ever personally been victimized by King George III. Ha. My husband relates very hard to King George III, which is why he bought me this mug, because he says I'm personally victimized by him on a daily basis. Totally true. Let's inequality this thing. Before I show you absolute value inequalities, remember that when solving an inequality, if you multiply or divide both sides of an inequality signed by a negative number, you're going to end up with having to flip your inequality sign. And that's a value issue. Okay, and that's when you multiply by a -1, you have now changed the value comparison of your two numbers on each side of your inequality. So the inequality symbol has to be flipped to make up for that change. Something you've been taught a long time, but still bears reminding, right? So we've got two scenarios still. You know what? I'm just going to do a problem. We've got two scenarios still, but if we multiply or divide by a negative number, we've got to make sure we're flipping the inequality sign over. So let's think about how we did it when it was an equation. We dropped the absolute value bars and we brought down our equal sign and we left the other side alone. Well, that's easy. Add 20. X is greater than 25. Okay, that's not bad. That was the first scenario. Not bad. I got an answer. But the second scenario was that you dropped your absolute value bars, so you brought this down, but you had to negate the other side, which meant you were multiplying the other side by -1, which means I am flipping that sign over. So in this case, the second scenario is going to be a sign flip and a negation. Okay, so there's two things you have to think about instead of just the negating the other side. Now that it's an inequality sign you're doing that with, you also have to flip the inequality sign. So now we still use that same opposite operations to get x alone, but this inequality sign is flipped over, and 20 minus 5 is 15. So you've got two things here. And when you go to graph them on a number line, I just want you to read what they say, right? X is greater than 25. X is smaller than 15. Are you ever going to have anything that's greater than 25 and smaller than 15 at the same time? No. This is an OR. So the thing that we have to think about when solving absolute value inequalities is the solution sets are going to be either between inequalities, meaning ands, or they're going to be outside going in opposite directions, which is going to be ors. When I start to do this, you're going to start to pick up on a pattern, and I will point it out by the end. Okay, but just bear with me, and we'll start to put these on the number line. Now remember, I get to scale my own number line, so it's here, and I've got all my hash marks, and it's scaled. And so I'm just going to go by fives, right? So I'll do 0, 5, 10, 15, 20, 25, 30, 35. So I got a couple numbers on there. I'm scaling it myself. So here's my 25, and x is greater than 25. So there you go. And then I'm scaling it myself. X has to be less than 15. So here's my open circle over 15. And everything smaller than 15 gets covered. That's my OR inequality. And as you already know that OR inequalities are going to go opposite directions like this. And this solution set does not have any shared answers. So that's why we're going the opposite directions on a number line. So that's not too bad. Okay. So let's do another one, right? Remember to make sure your absolute value bars are alone. Okay, so your absolute value bars need to be alone first, and they are over here. Cool. Okay, well, let's just do our two scenarios. Drop your absolute value bars, bring down your inequality sign, bring down your number on the other side. So there's your first scenario, and let's do that. Okay, add 3. X is less than or equal to 7. Okay. Now let's do our second scenario where we drop our absolute value bars and we have to negate the other side, which means flip the inequality sign and negate your number. Okay, so now when I go to solve, I get x is greater than or equal to -1. And let's think about this. Can any solutions be both smaller than 7 and greater than -1? And the answer is yes. This is an and, but what I like to do is I like to write them as the between inequality, and here's how I do that. I actually get these on the number line first. So let me scale because I have the opportunity to scale myself. So -1, 0, 1, 2, 3, 4, 5, 6, 7, and I'll do a couple more on each side just to have some movement there and some stuff we can see. Over the 7 goes a closed dot. Over the -1 goes a closed dot. They're either both going to be closed dots or open circles because your sign is from the beginning either going to have an equal to or not, like it did over here. Now, think about it. X has to be less than 7. Okay, that goes over here. And X has to be greater than -1. Okay, that goes over here. And see how they meet? That's how I know it's a between inequality. That's how I know it's an and. Now, you are welcome to stop and do this right here and not rewrite, but I always rewrite -1 is less than or equal to x, which is less than or equal to 7. So when I create a between inequality on my graph, I always rewrite my answer as a between inequality. And it's just helpful for me understanding that x is between these two values. Okay, so it's just a helpful thing for me. I just want you to understand that this is perfectly acceptable right here, but you have to write the words and or. Okay, so you have to indicate which type of inequality it is. Is it an and or is it an or? And of course, the actual number line solution set helps you to see that. Okay, so that's one of the ways it helps you. All right, moving on. Gonna ignore C. Don't worry about C. But D, we need to talk about D. D is the way that we love to mess with you a little bit when it comes to inequalities. Because the first thing you have to do before you can solve absolute value is to get your absolute value bars alone, which means the first thing I have to do is divide everything by -10, right? That's what's going to get my absolute value bars alone. But I'm dividing by a negative. So guess what's got to flip before I have my absolute value bars even alone? The sign. In this scenario, you don't get to say no solutions for negatives because this is saying that the answer is going to be greater than -4. That's possible. It's possible for absolute value to be greater than -4. So you still got to go. Now, you still have your two scenarios because now that you have your absolute value bars alone, now you pull the numbers outside of the absolute value bars, just normal. That's the normal side, right? We're doing this either way. And scenario 2 is you're pulling the stuff out of the absolute value bars and you're flipping the sign again and you're negating the other side. I know. This is where we're going to test you a little bit as multiple flippages of signs. And so you have to be really careful about following your rules. Okay. So we do get x's less than 7 over here, and we did get x's greater than -1. I'll just scale my graph the same way I did above, because though they are using the same numbers in question, right? So 7 gets an open circle and -1 gets an open circle. And let's see, x is greater than -1. Well, that goes this direction. X is less than 7. Well, that goes this direction. And these guys meet in the middle. And because they meet in the middle, this is an and inequality. And so you are welcome to stop and box this in right here as long as you write the word and between them. Or if you're like me, you're a betweeny inequality peep and you rewrite. I always rewrite those. I always rewrite the betweeny inequalities. Okay, so just kind of get used to that. But be careful with stuff like this because you do have to get your absolute value bars alone before you can do your two scenarios. And you do have to watch for multiple sign flippage. That's right. I made up that word. Multiple sign flippage. Be careful, okay? Because it's going to happen on the homework. I'm telling you that because I wrote the homework. And this is where it separates the Algebra 1 people from the Algebra 2 people, is stuff like this, where you've got to make sure you're following your rules about inequalities as you go. Okay? So I will be on the lookout for that. I will also be available to talk to you about that stuff. I am more than happy, as we know, to talk about math. So please see me if you need anything for any of these problems. I love absolute value equations and inequalities. I think they are stellar and kind of a quote unquote easy algebra 2 thing because it really is just solving two little mini equations that you have. Okay. And then just putting them back together on your number line solution set or as your final answer. Right. So go right ahead. Let me know if you need me. Happy to help. Otherwise, I'm here as an ice cube freezing in Antarctica. So, I'll see you guys.